Hello guys, my name is Lahari, studying in Sri Venkateshwara College of Engineering from the Department of CSE Data Science. Today we are going to see about corrosion, classification of corrosion and types of corrosion. First, let's look into corrosion. Definition of corrosion. Corrosion is defined as the destruction of metals or alloy by surrounding environment through chemical and electrochemical changes. The chemical composition of rust is Fe2O3 into X moles of H2O. Now let's look into the second topic, that is classification of corrosion. Based on the environment, corrosion is classified into two types. They are dry or chemical corrosion and wet or electrochemical corrosion. Now let's look into the dry or chemical corrosion. This type of corrosion is due to the direct chemical attack of metal surfaces by the atmospheric gases such as oxygen, halogen, hydrogen sulfide, sulfur dioxide, nitrogen or anhydrous inorganic liquid, etc. The chemical corrosion is defined as the direct chemical attack of metals by the atmospheric gases present in the environment. Example, silver material undergo chemical corrosion by atmospheric H2S gas. Second, iron metal undergo chemical corrosion by HCl gas. Now, let's look into the second classification of corrosion, that is wet or electrochemical corrosion. Electrochemical corrosion involves the formation of anodic and cathodic areas or paths in contact with each other. Presence of a conducting medium, corrosion of anodic areas only, and formation of corrosion products somewhere between anodic and cathodic areas. This involves flow of electrocurrent between the anodic and cathodic areas. At anodic areas, oxidation reaction takes place, that is, liberation of free electrons, so that anodic metal is destroyed by either dissolving or assuming combined state, that is, such as oxide, etc. Hence, corrosion always occurs at anodic areas. M is equals to metal Mn plus Ne minus. Mn plus is equals to dissolved in solution to form compounds such as oxides. At cathodic areas, reduction reaction takes place, that is gain of electrons. Usually cathode reaction do not affect the cathode since most metals cannot be further reduced. So at cathodic part, dissolved constituents in the conducting medium accepts the electron to form some ions like OH minus and O2 minus. Cathodic reaction assumes electrons with either by evolution of hydrogen and absorption of oxygen depending on the nature of the corrosive environment. Now let's look into the electrochemical theory of corrosion, taking iron as an example. According to electrochemical theory, when a metal such as iron is exposed to corrosive environment, following changes occurs. A large number of tiny galvanoic cells with anodic and cathodic region are formed as shown in figure. Reactions. Reaction at anodic region. Fe gives rise to Fe2 plus 2E minus. At cathodic region, liberation of hydrogen. In acidic medium, the reaction is 2 moles of H plus 2E minus gives rise to H2. In neutral or alkaline medium, the reaction is 2 moles of H2O plus 2 moles of electrons gives rise to 2 moles of OH minus plus H2. Absorption of oxygen. In acidic medium, the reaction is 4 moles of H plus O2 plus 4 moles of electrons gives rise to 2 moles of H2O. In neutral or alkaline medium, the reaction is 2 moles of H2O plus O2 plus 4 moles of electrons gives rise to 4 moles of OH minus. Now, the overall reaction is Fe plus half mole of O2 plus H2O gives rise to FeOH twice. 2 moles of FeOH twice plus half mole of O2 plus H2O gives rise to Fe2O3 into 3 moles of H2O. Now let's look into the next topic, that is types of corrosion. There are two types of corrosion. They are differential metal corrosion and differential aeration corrosion. Now let's look into the first type, that is differential metal corrosion. This corrosion occurs when two dissimilar metals are in contact with each other and exposed to corrosion environment. The metal with lower electrode potential acts as anode, undergo oxidation and get corroded. The metal with high electrode potential acts as cathode, undergo reduction and prevents from the oxidation. Reactions. At anode, H2 plus 2 electrons gives rise to H2. At cathode, 2 moles of H2O plus O2 plus 4 moles of electrons gives rise to 4 moles of OH. Examples of differential metal corrosion are tin coating copper vessel, steel pipe connected to copper plumbing, and bolt and nut made up of different metals. Now let's look into the second type of corrosion, that is differential aeration corrosion. When a metal is exposed to different concentration of air or oxygen, part of the metal exposed to lower concentration of oxygen becomes anodic and undergo corrosion. But whereas other part of the metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. Examples of differential aeration corrosion are part of the nail inside the wall undergoes corrosion. When a dust particle sits on a metal bar, the part under the dust undergoes corrosion. Third, partially filled ion tank undergo corrosion inside water. Typical examples of differential aeration corrosion are waterline corrosion and pitting corrosion. Now let's look into the waterline corrosion. It is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, the inner portion of the tank below the waterline is exposed only to dissolve oxygen, but whereas the portion above the waterline is exposed to more oxygen. Thus, upper portion acts as cathode and is unaffected. The distinct brown line is formed just below the water line due to the disposition of rust. The cell reactions are at anode, M gives rise to Mn plus Ne minus. At cathode, 2 moles of H2O plus O2 plus 4 moles of electrons gives rise to 4 moles of OH minus. Finally, the ions combine to form corrosion product. Example: ships which remains partially immersed in seawater for a long time undergo waterline corrosion. Now let's look into the pitting corrosion. This type of corrosion is observed when dust particles or oil drops deposited over the metal surface. Pitting corrosion is due to metal surface is not homogeneous, external environment is not homogeneous, crystallography directions are not equal in the reactivity, and environments are not uniform with respect to concentration. Pitting corrosion results when the portion of the metal covered by dust which is less aerated becomes anodic and undergo corrosion and to form pit. The remaining area of the metal which is exposed to higher concentration of oxygen becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because formation of small anodic area, that is pit, to corrode faster because accepting electrons from the cathodic area increases. The cell reactions are at anode, Fe gives rise to Fe2 plus 2E minus. At cathode, half mole of O2 plus H2O plus 2E minus gives rise to 2 moles of OH minus. The net cell reaction is Fe2 plus 2 moles of OH minus gives rise to FeOH twice. Thank you guys for watching this video. Please like, share and subscribe my video.